Hey everybody. Okay, so I wanted to keep going maybe a little bit with the linear model, and keep showing you guys some things that can go on with the linear model. So let me rerun back through what's going on here in my RStudio. I'm on to my second part. My first video showed how I just linked the two pieces of the project together, so they're two different pages. Again, that was partially so that I can knit some more complicated things together. I have to be careful about filling my RAM. So I've just done that with links, and they're not hard to include here. Okay, and then the very last thing I did, and I wasn't sure I was going to do it, but I did it, was I did a linear model, and I predicted the number of wins based on the number of points. And the way we do that, the way we do a regression here in um, R is we do that with the LM command, linear model. And so what we do is we put our predictor, the thing we want to predict, the W, we put a tilde, and then we put the thing we want to predict it with, points. We do a comma and we do data equals our data set, and my data set is called data. So when I run this, it gives me this little output, which isn't terribly interesting. Looking at that, it does give me the coefficients. So we take the number of points, we multiply by a half, and then we would subtract a quarter, and that would give us our predictor of the number of wins. Kind of makes sense. You get 2 points for every win. So there is an interpretability to those. You should interpret your statistics. You should interpret those. And by the way, the minus 2.5 means everybody starts out with a negative a quarter point, whatever that would mean. One of the things that's really cool though, guys, is that there's a bunch of calls you can do. So instead of just calling the LM, if I store it as a model and I store that, notice nothing comes up. One of the really cool things here is the summary. I like the summary a lot. It gives a lot of information about what's going on here. It talks about the residuals, the coefficients, and degrees of freedoms, and F statistics, and oh my god, so many things. Okay, so let's kind of talk through some of these. Points, again, was what was passed as the X value, so this is the slope of the X value. I also get the standard error, which would help you compute a confidence interval of the estimate of the slope. I also get the t-value, and I also see the significance. This one is very significant, highly significant, right? Three dots, essentially 0. The intercept is not very significant. Remember, a moment ago when I said that it was negative a quarter, I had a hard time interpreting that, right? It doesn't look like it's statistically significant. And of course, I have the standard error and a t-value for it. So this one is not statistically significant. Maybe I wouldn't use that. There's also these things called the residuals. The residuals are how much error you have. Of the sum of all residuals, it's actually going to be 0. The residuals should be normally distributed, and I think what we're going to see here is they're actually not. The linear model can be run on anything, but it's not always appropriate to run. All right, let's show you a couple more things that are pretty easy to do with the model once you call it that. There are these things called the plots. So you can call the plot of the model, and you probably should do this. And the plot of the model has a whole bunch of things about the residuals. Let's go to the one that's really important, the normal QQ. This is looking at the normality of the data that you gave it. And I want to point out that my data isn't very normal. So the number of wins is pretty not normal. There's not enough data in the season yet. So this should lie on this vertical line. These are the residuals versus the fitted. This one, what do I want to say about it? This one should show no pattern. So yeah, it doesn't show a pattern. And then I'm really, really uncertain about these other two. Let's just say that they're there. At some point in my life, I knew what some of these meant, and I can't tell you right now. So let's not worry about them too much, okay? This one we should get used to looking at, though. It's going to tell us normality of the residuals, and the residuals don't quite look normal. So that might be an issue. The plot here is supposed to help you assess the validity of doing the linear model. Let's see, what else can we do? The predict command is pretty cool. I like the predict command. So if you predict on model, it will give you all the predictions. There are 30 teams. There are 31 teams in the NHL, but one of the teams hadn't played yet. And this is the predicting of the number of wins that each one had. If I wanted to instead predict that, if I wanted to predict, say, a couple of say a team had 10 points, and a team had 12 points, and a team had 15 points, I could also pass it, no I cannot. I have to say new data equals, did I not do that correctly? Hold on, I'm gonna hit pause. Okay, guys, sorry. That was trickier than I thought it was. So, alright, let me go through what I just figured out. Okay, so I wanted to do prediction. The predict will run, let me do it again. So the predict will run by itself, predict, and you pass it the model. When I run that, it gives me a prediction of all the original points in the data. Now remember, its input is points. That's what I gave it, right? Its input is point, and its output is wins. So these would be the number of wins based on the number of points. Again, these are the predictions of each one. Okay, if I wanted to make a prediction on other ones, I've done it below here in this code, and it was tricky. It took me a minute to figure this out. So the first thing I do is I do this C command. C is what allows you to make a list of something. Here I've made a list that goes from 10 to 15. By doing that, you could just list them out individually. So 10, 11, 15. I called that Y list. Equals or assignment is fine, either way here. Then what I have to do is I can't just pass a list into the predict model. I have to pass it a data frame where that list is called points, PTS, because that is how the model originally worked, is it took points and made a prediction on wins. So I got to change that list into a data frame, and that's what I've done here, and I've called that point. Then I predict using the model on the new data called point, and this will now run, and it'll make a prediction on each of those three, 10, 11, and 15. Tell me I should have 4 wins, 5 wins, and 7.3 wins. Okay, so there you go. That's how you're going to make predictions. This is a little tricky, but you do have to pass it a data frame with a column name that's appropriate. When I put a different column name, it wouldn't do it. So you really do have to redefine that column name. And of course, C just makes a list of things. All right, so that is a few things about the linear model, and I'm going to cut it there because that's about time.